Hi guys, and thank you for joining me today for part 3 of our video series. In the previous video, I mentioned that this part is going to cover the complete assembly process of the amplifier build. However, during recording, I realized that I needed to spend a bit more time talking about the components that I chose and why I chose them, and therefore the video was becoming a bit too long. So what I've decided to do was to split the content. So part 3 is going to contain a detailed list of the components required for the build. I will also talk about how and where I sourced each of these items and the approximate or respective costs. Part 4 will then follow from part 3, and that's going to be where I discuss the assembly of the amplifier. Okay, so looking at the components required for the build, the key components required to complete this amplifier project are amplifier module, power supply unit for the amplifier, cooling fan, preamp or tone control board. Now, you would not need this if you want to be pure and you don't want to add color to your sound. Some preamp or tone control boards require a center tap transformer, and if so, you're going to require one of those. If not, you won't require this transformer. You're also going to require a time delay relay to make use of the soft start functionality on most of the TPA 3255 amplifier boards have. You're going to need buck converters or DC to DC step-down converters for your ancillary power needs. For example, to power your fan or to power your time delay relay. You're going to need a main power switch. Importantly as well, you're going to need an enclosure to house all of your components. You're going to need shielded audio cables between your audio inputs. You're going to need general purpose cables, flexible cables, and this is going to be for the electrical connections, speaker connections, and so on. You're going to need PCB standoffs to enable you to safely mount the PCBs into the enclosure. You're going to need RCA input jacks for your input audio signal, and you're going to need speaker binding posts or terminals, so you'll have somewhere to connect your speakers. Please note that this list may not be exhaustive, and a few minor components may have been unintentionally omitted. So, number 1, the amplifier board. Now, the amplifier board was the first and most critical component that I selected. I had several criteria in mind, right? So, firstly, it needed to feature the TPA 3255 chip by Texas Instruments, as this chip is known for its high power output and excellent value. The input stage op amps needed to be socket mounted for easy op amp rolling, and I may talk about this in a future video as well. Also, I preferred a board with a minimum operating voltage of 36 volts, with 48 volts being ideal to achieve a better sound stage. And if you recall, I spoke about this in part 2. Another important thing that I needed was a nice large heatsink with many fins, and for me this was a priority in terms of the thermal management to maximize the surface area for heat dissipation. As I've previously discussed, while Class D chips are efficient, heat is still a concern due to their compact size. I looked for boards with some branded quality components. Generally, this indicates a greater attention to build quality, especially for budget-friendly Chinese-made boards. I also looked at the user reviews. These were essential. And I also referred to various sources, including videos by YouTubers such as Michael Beanie and Kiss Analog, to guide my decision. Lastly, the board needed to be affordable, as this was my first venture into Class D amplification and I wished to minimize the financial risk. So what did I end up getting? Right, so in the end, I purchased a board from Temu for 331 Rand. It did not meet all my criteria, but it was a practical compromise. High-end boards were either too expensive, not available from preferred sellers, or not even shipped to South Africa. Since my purchase, however, I have seen better variants available from Temu. And these boards are becoming more popular, and some great stuff is being made available from companies such as Woozy Audio. So the most notable compromise was the maximum operating voltage. So although the TPA 3255 chip supports up to 51 volts on the input, the amplifier board's capacitors were only rated for 50 volts. So this offered too little headroom. So basically, to input 48 volts while your capacitors are rated at 50 volts was just too much of a concern for me. I also learned from other users that these boards could fail prematurely when run at 48 volts due to subpar voltage regulators. So consequently, I opted to operate my board at 36 volts. So this was quite a conservative 36 volt choice, but obviously I didn't want to blow up the board on my first try. So as you can see, this board is very basic. Essentially, it's just a power amplifier module only. It does not have any tone controls or extra features. As I mentioned earlier, there are better variants out there now with integrated tone controls, etc. So if you are needing those extra features, getting a board with integrated tone controls, etc., rather than getting separate modules for those features, may reduce your overall costs. Okay, so then now looking at the power supply. To power the amplifier board, I selected a 36 volt 8 amp switching or switch mode power supply from Temu, and that costed me 160 Rand. This was the highest rated unit available on that buying platform. Although linear power supplies are preferred by many audiophiles, they are significantly more expensive, and I was wanting to build something of low cost, so I decided to give the switcher a try. Also, many commercial amplifier products use switch mode power supplies successfully, and I was kind of confident with this choice as well. If you're worried about noise, the switching frequency of the switch mode power supplies are also way above the audible range, so you don't really need to worry about noise coming from your power supply as well. The next thing was the cooling fan. So I mentioned in the previous video as well, given the heat generated by the amplifier and the generic nature of the heat sinks provided on these amplifier boards, I deemed additional active cooling essential. I purchased a 5 volt 80mm fan with a grill from Temu, and that costed me 54 Rand. Although I tested a 12 volt fan, it did produce excessive noise due to the air turbulence. It did obviously push or move a lot more air than the 5 volt fan, but the turbulence was just too much. So I opted to use the quieter 5 volt version, which provided sufficient airflow. The larger diameter of 18mm also helped me ensure that both the amplifier and the power supply would remain cool within the shared enclosure. Some of the improved variants of the amplifier boards available now do have integrated fans. So again, this could potentially reduce your overall cost rather than getting separate fan components. Next, let's talk about the preamp or tone control board. So to enhance audio control, I included a preamp or tone control board in the design, as my amplifier board, as I mentioned, did not feature these as an integrated option. The unit I chose also came from Temu, and that costed me 94 Rand. And that featured gain controls for your low, mid and high frequencies. So basically your bass, mid and treble. And it had a volume control as well. So 4 knobs. My initial choice was the XHA901, which operated on 12 volt DC. But I found that that board introduce unacceptable noise. And despite trying known modifications to this board to address the issue persisted. I eventually replaced it with a gold A044 board, which required a center tapped AC transformer as its supply. This added to the cost, but overall it provided better isolation and audio quality. Next, we're going to talk about the center tapped transformer that I got to power my preamp board. So I managed to source a center tap transformer which was rated at 15015 at 500 milliamps from Mantech Electronics for 140 Rand. Again, if your amp has integrated tone controls, then you won't need this, right? Because you're not going to have a separate preamp or tone control board. Moving on to the time delay relay. To avoid unwanted speaker thumps at power on, I introduced or included a time delay relay module, and this costed a mere 27 Rand from Mantech Electronics. It ensures that the amplifier output is only enabled after a short delay, so once the system has stabilized. So most if not all of these boards that you buy these days, these amplifier boards, they do have a soft start feature, and it just requires either shorting or opening of designated contacts. So basically in my design, that's what the relay did. So the next component that I chose was a power switch. The power switch that I used was a self-latching round push button with an integrated 12-volt LED light ring, and I purchased this again from Mantech Electronics for approximately 80 Rand. But there are similar switches available from Temu for about 50 Rand. I chose a round shape as it would be easier to cut the hole on my enclosure using one of the step drill bits or larger diameter drill bits that I already had. The next component was the buck converters. I used the DC to DC step down converters to reduce the main 36 volt supply to 12 volts and 5 volts to power the fan and time delay modules. Now I opted for models with LCD displays, which you will see, and those costed me 30 Rand each from Temu. I got the ones with the LCD displays because it was a bit more convenient to adjust the output voltages, but you don't have to. In fact, the option without the LCD is significantly cheaper, and that's the price that I actually listed and gave the part number for, right? And we will touch on the prices a bit later in the price breakdown. Next component, which is a very important one, was the enclosure. Now, to determine the appropriate enclosure size, I conducted a basic component layout. I stacked components where possible to reduce the overall size of the enclosure. The final enclosure was purchased from Mantech Electronics for 300 Rands and is made of metal. I felt that metal provides a nice durable and solid feel. A bonus was that the enclosure also featured side ventilation slots, so I didn't have to drill those in, which saved me a lot of time. You could also opt for an ABS plastic enclosure, which will cost significantly less. But just make sure you do a basic component layout to determine what is the minimum enclosure size that you are going to need. The next two components were the RCA inputs and speaker binding posts. So for the RCA's inputs, I purchased a pair of gold-plated sockets from Temu, and it costed me 28 Rand for the pair. In fact, I was actually quite impressed with the quality of these sockets. In terms of the speaker binding posts, these costed me 34 Rand for the pair from Temu. And while these are functional, I do recommend investing in slightly higher quality binding posts for better durability. In terms of the cabling, I used shielded 2-core cable for the audio signals or shielded 3-core cable for the audio signals, and I sourced that from Mantech, and that costed me 20 rands for 2 meters. In fact, 2 meters was more than enough for this build. With regards to the other wiring, that consisted of mainly reused cable, which I already had available. If purchasing new, expect to spend anywhere between 50 and 100 rands for suitable 1.5 millimeter squared flexible cables. And the last component to attach the PCB to the enclosures or the enclosure, I purchased PCB standoffs, and I used the 3mm brass standoffs, and I got them from Temu, and I got an entire, I think it was a 177 piece set, which costed me a mere $100. And it had a variety of lengths and number of components in the set, and it was more than sufficient for this project. Okay, so taking a quick look now at the cost summary. Here you'll see the basic cost breakdown, right? Some of the components were purchased from Temu, and the other components were purchased from Mantech Electronics, which is a local electronic store here in Durban, South Africa. And I've tried to put down part numbers wherever I could to assist you. For the components that were purchased from Temu, I applied a flat 20% customs duty estimate for those items, though I likely paid less. I have included the part numbers, as I said, and the suppliers. So if you wish to purchase the very same components, hopefully you're going to have, or you will be able to do that with ease. And if you're based in South Africa and you're unable to find any specific part, please feel free to contact me in the comments, and I'd be happy to help, and I'll assist you to source the same or even equivalent parts. Now, the prices listed here are as at February 2025. The prices from Temu as well also seem to fluctuate, and you could score some of the above components for a cheaper price. Now, here's a top tip for you guys. If you've been buying a lot of stuff or items from Temu, I suggest that you add items to your cart and just let it sit there. You will see the prices change daily. It tends to fluctuate, and after a few days you will tend to notice what the rock bottom prices for the items are, and then you can just purchase the item when you're happy with the price. That's how I generally get the best deal from Temu. And no, I am in no way sponsored by Temu. I just prefer purchasing from the platform as I have had no delivery issues so far. Okay, so final remarks. I hope you found this video informative and that it assists you in planning your own amplifier project. In part 4, I will go through the physical assembly of the amplifier. And please don't forget to like this video and subscribe to the channel. Be sure to enable notifications so you're alerted as soon as the next part is released. Thank you for watching, and I look forward to seeing you in the next one. Thank you so much.